Welcome to Chem Fullmark A. We are going to discuss the strategy to answer questions 7 and 8 of 2015-2016. 7A. This is an organics question, so it is important for you to follow every line of the question and try to make the mapping of the question. The first line. Compound B is formed from the reaction of benzene with chloroethane in the presence of AlCl3. So you need to have the chloroethane react with benzene in the presence of AlCl3. Next, it forms BB. Next, oxidations of BB with hot acidified solution gives CC. So continue from BB. Next, this time is using KMNO4, acidified, hot, so you have CC. So treatment of CC with ethanol in the presence of traces of sulfuric acid produces DD. So now C is the reagent, the reactant, and react with ethanol, and acid sulfuric. You have DD. So the task you are supposed to complete is naming the type of reaction, the first task, that converts benzene to BB, which is conversions of benzene to BB. So this is the first task. Suggesting the structures of BB, CC, and DD. So this is the second task. What is BB, CC, and DD, the structure? And then you have to write the equation for formations of BB and DD. So formations of BB and DD, reaction, formation of BB, so you have the reaction of formation BB and DD. So this is your third and fourth task. And finally we have the mechanism. Write the mechanism for the formations of BB. So this is the fifth task. So altogether you have 5 tasks. So how to get a good strategy for answering this question is looking at the mapping that you have made. You can see that name the type of reaction. So benzene, and now you have the BB. So try to guess what is a BB. When you have benzene and you have your chloroethane, so meaning that the BB is an alkyl benzene with the structure of alkyl benzene. That is the structure for your alkyl benzene. Next is when you have your alkyl benzene, and this is oxidation, undergoes oxidation. You have your CC. So CC is normally carboxylic acid, because when alkyl benzene undergoes oxidation, you have carboxylic acid. And when carboxylic acid react with ethanol in the presence of sulfuric acid, then you know that this is esterification. So DD is an ester. So this is how you try to get your structure and your answer. So by doing this, you are guided to look for your answers. And for the reactions of BB and DD, so you need to have a good memory to remember the whole set of answer. So we can see that reaction equation for formations of BB is actually the formations of alkyl benzene, and equation or reaction for DD is esterification, and for the mechanism of BB is actually the electrophilic aromatic substitution. So here are the answers that you are supposed to know. If you are having it correctly for the mapping, you will see that the type of reaction is electrophilic aromatic substitution, and the structure for BB, that is the alkyl benzene that we try to figure out the structure, and this is the carboxylic acid, and this is DD for the ester, and this is your alkylation of benzene for the formations of BB, and for the actions of DD where you have the esterification and it form an ester. As for the mechanisms of formations of BB, you just follow the steps of alkylations of benzene. Next we go for question 7b. Like what we did in 7a, we need to have the mapping. So here it says that an alkyl bromide EE, alkyl bromide EE meaning that you have the haloalkane, react with the ethanol, and we have FF. And we have that structure formed when EE treated with nucleophile. So this is the EE and treated with nucleophile. So what we have is the structure of CH3, C double bond O, O, CH, CH3, CH2, CH3. Next is dehydrohalogenation of EE produce GG, which obeys Setzev rule. So EE dehydrohalogenation or in other words minus the HBr, then you are going to get GG. So what do we know about GG? GG obeys the Setzev rule. So this is the mapping that we have, and from here you need to deduce the structure of certain product, that is your EE, deduce the structure FF and GG. So when you have the word deduce, meaning that you have to give some explanation how you get structure of EE, FF, GG and the nucleophile. So EE, FF, GG and don't forget the nucleophile. So this is the first task. Next is you have to write all reaction. Okay, second task is all reactions. So how to get the structure of EE, FF and GG? So the best part would be, for easier to know, is try to look for the nucleophile. So if you want to look for the nucleophile, remember that nucleophile is rich in electron, species that is rich in electron. So you are looking for the answers based on the structures given. So what would be the nucleophile? How are we going to know the nucleophile? Is where you have to look for the cleavage, the bond cleavage. Where are we supposed to have the bond cleavage? So you are looking for something that is negative, O with the negative, and at the same time it needs to obey the Setzev rule for the product. So by doing this, you know that you are going to get the correct answer, so you have to double check. So since nucleophile is an electron-rich species, meaning that you are going to have the cleavage somewhere there, and that will give us the more electronegative species as the nucleophile and more electropositive as the haloalkane. So based on this one, you can check the answers as the answer produced is the bond cleavage between the C and HO. So this is the nucleophile, and the alkyl bromide EE is this one, the alkyl bromide. So that is how you get your answer. And for all the reaction, you have 3 reactions involved. 1, 2, 3. Next we go for question number 8. Using an amine of your choice, explain the basicity of primary aliphatic, and secondary aliphatic, as well as aromatic amine. So you have the first task, and the second task is an orange dye or p-phenylazophenol has the following structure. Show the synthetic group. So showing the synthetic group is the second task. So for A, you have 2 tasks to be completed. So since you are going to explain the basicity of amine within your choice, so you may have your primary aliphatic amine and secondary aliphatic amine, which is more basic than primary due to its more electronegative group since the whole thing. And then that is the answer for your A, how to explain your basicity. Synthetic pathway for the preparation of phenylazophenol dye is you start from the aniline. This is aniline, and you have the dye. So this is where you need for the coupling reaction of amine. And remember that this is the naphthol. And you can refer it to your book. And the next question is you have to write the structure of dipeptides from 2-aminoethanoic acid. This is question 8b. And altogether you are going to get 4 dipeptides. So the dipeptide is where you have the C double bond O and N. This is the dipeptide. So here is the dipeptide for the whole set. And you have AA, and you have BB, then you have AB and BA. So altogether you have 4 dipeptides bond. And then for C, you're supposed to give the terms of homopolymer and copolymer, as well as giving the example. So since this is a polymer, so you need to have the square bracket and so that will shows you a polymer. And copolymer is nylon 66 because it needs to have 2 different types of monomer. So that will be the copolymer. So that's all for the discussion. Thank you.